Hi everyone, in this lab, we will talk about the rehost migration strategy, which is basically a lift and shift operation from on-prem to the cloud. We will take a simple monolith application architecture and see how many components are there, what is the interaction between them, and what is the code base currently it is based on. Let's get started. So on the on-prem infrastructure, we have one server. This could be a virtual machine or a physical machine. And in the server, we have the front-end UI application running. It is based on Nginx, and this is called Tier 1. So this is the primary interface to the end users. Then we have one more application, which is based on Spring Boot, and this is doing actually the business logic. This is the second layer, which is called Tier 2. This is also called a business layer or an application layer. And this contains various components, for example basket handling, unicorn handling, user management, and health of the server. All of these four functionalities are embedded into the same code base. Okay, and both the front end UI and the back end, the app layer, basically are communicating within the same machine. Then we have one more server on the on-prem infrastructure, and this is where we are hosting the database. And this is a simple MySQL community-based edition. And to represent the basket, unicorn, and the users, we have three different tables in the database schema, which is unicorns, unicorn basket, and unicorn users. So these three tables are modeling the actual functionality in the application. Now the app layer will communicate with the database layer using the private connectivity within the on-prem. Okay, so this is the current infrastructure. Now, if you wanted to rehost this or lift and shift this architecture to the cloud, then we can talk about the strategies. So before that, let us see that the clients, it could be based on the mobile clients or from the browsers talking to this application using the front-end UI. Now, in the rehost architecture strategy, we will be using a service called Application Migration Service, which is also one of the AWS service, which is used to migrate to the cloud. Okay, and in the AWS cloud, we will be using the EC2 missions for both the front end and app layer and also the back end. Okay, so this is how we kind of rehost the existing monolith into the cloud as it is without doing any refactoring. Okay, without doing any re-platform also, it's as it is. Okay, so this is how a typical lift and shift operation looks like. Now let us see how this looks like in the cloud. Okay, now in the AWS cloud, we will provision one public subnet to host the UI, because the UI has to be accessible from the users over the internet. Then we will deploy one EC2 machine, and within the EC2 machine, we will have the same components, the front-end UI and the app layer, and both of them are running on the same EC2 machine and connected between them. On the since they are talking, they are the same EC2 machine, they can talk to each other without any issue. Then we have a private subnet, or we can have a dedicated database subnet also created in the AWS infrastructure, and this is where we'll be deploying an EC2 machine to deploy the MySQL database server. Okay, and they can talk to each other because they are in the same VPC through the private IPs. So this is how a typical lift and shift operation looks like, and we will now go into the code and see how this is codified. Okay, and as usual, the clients will talk to the front end UI through the public IP of the EC2 machine to access the services. Okay, so let us go through the code and deploy this infrastructure and see how it works. Hi everyone, in this video, let us understand how to deploy the monolithic application on two EC2 servers. Okay, so in this entire lab series, we will first focus on deploying a basic infra setup where we have a monolithic application running on two EC2 instances. So let us create the VPC and the web app and the MySQL servers. So we created a brand new VPC to host the EC2 servers. One of the EC2 server will be running a web app which runs the Nginx and also a Java application, Spring Boot application. The second one is running a MySQL server database on the EC2 machine. Okay, so let's go to the folder, look at the source code and do the Terraform init, plan and apply. Okay, so this is the source code for the web app and this is source code for the DB. Okay, let's get started. So I'm initializing the user data section for the database instance. So here we are installing few packages using the yum and installing the community edition for MySQL server on this machine. The version is MySQL 8.0 community release. So this is the one we are deploying and we are setting some passwords, some temporary passwords to the MySQL server and starting the service. So simple configuration. Then there is a GitHub where we host the content for one of the sample Spring Boot Java application. So we are including that into a particular folder and we are creating the database tables. So we are just bootstrapping the database with some tables. The tables are created using this SQL file. Okay, this is there in the repository. Now this is a user data section and we are creating an EC2 instance using this Terraform module. And here I'm just selecting the Amazon Linux 2, latest AMI, m5.large machine. The VPCs that we created as a part of this module. So we are using the private subnet to host the database. Ideally, we should host the database in a database subnet, but since we are downloading some packages during the bootstrapping, it requires internet connectivity through private public NAT gateway. So the database subnets does not have that connectivity. The routing is only within the VPC. So for this demo purpose, I'm using a private subnet which contains a route to the internet via public NAT gateway. Okay, and there is a security group associated with that. It should contain the least privileged permissions in terms of the ports and the protocol that it can allow. So public IP false because we don't need any public IP for the database instance. So some IAM role I'm creating. So we don't require many IAM roles, just for the demo purpose I just included. Then we are configuring the user data section, creating some volumes. We can use these volumes depending upon the database that we are going to host. Now this is a security group. If you see the ingress rules, this is the egress. So we are allowing all the traffic to internet because since we are downloading some packages during the bootstrapping, we require access to internet. So the egress block is all allowing all the protocols and all ports to the internet. Similarly, for the ingress, we are allowing only 3306 port. This is where the MySQL database server will be listening on. And we are allowing only from the web application security group. We don't need to access from, no need to allow any other security group or CIDR block. Only from web app security group we need to allow this traffic. And that's it. This is simple configuration. Now let's go to the web app configuration. In the web app, again we have the user data section. We are installing some SM packages, some Java packages because we are running the Java application here. Again, including the repo. Then we are building the Java application, Spring Boot application using the Gradle and other tool chain. Then we are also installing Nginx on the same EC2 server. So the Nginx is front-ending the UI. The UI is served by the Nginx, and the path for the Nginx is basically coming from the GitHub repo that we have cloned. Okay, so this is a default Nginx configuration /user share Nginx /html, but instead of that, we are pointing that to the repo directory, and that's a micro mono to micro UI folder. This is where the web page is being served. Okay, and we configured that in the nginx.config. And one more configuration we are doing is the proxy. So the Java Spring Boot application is running on the same EC2 machine as the web app, and it is running at 8080 port. So we are doing the direction, traffic direction for /API. So any calls to this path will be directed to the 8080 port on the same EC2 machine. This is where the Java web application is running. Okay, so we are configuring that in this file. So this is how the Nginx is configured. We are starting the Nginx. So some S3 buckets we are initializing. We will discuss that later. For this initial demo, we are not using any S3 bucket. This is for the later modernization path. So we are creating this mono to microservice as a part of the system initialization. And if you look at, we are just configuring the variables. So the variables for the database endpoint will be the database EC2 DNS name, this region. So this is the database instance private DNS name. And then we are starting the Java application here. So if you see, this is the jar file that we have built earlier. So this is the jar file, and the logs are being directed to this file basically. Okay, and we're also configuring a CloudWatch agent to ship the logs to a CloudWatch log group folder. Okay, CloudWatch log group folder. We will see that also as a part of the demo. So we are just reloading the daemon services, starting the application, and this is where we are configuring the security group. Yeah, this is EC2 instance. So again, we are using the Amazon Linux 2, m5.large machine. Here the subnets we are using the private public subnet because we are hosting this EC2 on the public subnet and we need to access it from outside. So that's why the public subnet is used and the public IP is enabled for this EC2 machine, and some permissions which we can further fine tune. So there are some root volumes also configured depending upon the requirement, but this is just a demo. So with respect to security group, so port 80 and 443 are allowed from the internet. Okay, and this is for the ingress. The egress also, we are allowing the same port 80 and 443. And apart from that, we are also allowing 3306, which is the database port to the database instance. So this is the primary configuration for the database and the web app EC2 instances. And some more files in this is basically, if you go to CloudWatch, we are basically creating one log group using this module. And the backend will configuring the Terraform state file into the S3 bucket. So remaining are all just variables, versions, and things like that. So let's go ahead and deploy this application. Let's do Terraform init ti in this folder. Terraform init is done. Terraform plan, let's apply. So Terraform plan is done. Now let us do Terraform apply with auto approve. It may take a while. I'll take a pause. So Terraform apply also completed. As you see, there's a lot of output here. Let us look at the output. We are creating this log group by name app-mod-web app, and we are creating multiple subnets, database subnets, and private subnets, public subnets. This is AMI ID, Amazon Linux 2 latest image we are using, and this is the database private instance IP, private IP. This is a web app IP. Then these are the other subnet IDs and names, and this is a VPC ID. So let's go to the VPC console and look at the subnets quickly. So if you look at the number of subnets that are created, so you can see that we are creating, let me just sort it, private control plane. So this is for the EKS clusters. In case we are deploying EKS later, I just created a control plane subnet for future purpose. It is a small size /28 16 IPs. Then we have DB subnet. This is where we are hosting the database. So it is also small /26, which is 64 IPs. So currently we are not running the EC2 DB instance in this subnet because it does not have an internet access. So instead we are running that into a data plane subnet. So data plane subnet DP are basically huge /18, which is 16,000 IPs. And similarly secondary IPs also I'm configuring for future use, but not for this demo initially, which is also from secondary CIDR block. Public IPs are also I'm creating subnets of /24, which is 256 IPs times 3. So this is a simple configuration for the VPC and subnets. Now let's go to the EC2 console and look at the EC2 missions which are created. So there are two EC2 missions created. One is the web app and another is the SQL DB. Both of them are running in the EC2. And web app is running with a public IP and the database is running with private IP. Okay. So if you go to the web app, so this is a public IP and the subnet on which it is running is a public subnet. Okay, so let's go to the security group. In the security group, you see that there are two rules, 80 and 443, both of them are allowed from internet. Similarly, if you go to the outbound rules, also we have the similar configuration. Port 80 and 443 are allowed, and also the database port 3306 destination is basically the database subnet. So this is how the EC2 machine is configured for the web app. So if you go to the database EC2 machine, so there is no public IP, only private IP, and it is running on the private subnet for now. Otherwise, we should actually run it on the database subnet. Now coming to the security group rules, there is only one rule which allows port 3306 from the web app security group. And outbound rules, if you see, it allows all the traffic to internet because it requires access to certain packages for installation. Okay. Now you can look at the page. So this is the public IP of the EC2 web app. So this is where the page is being served. So all of this unique data is basically available in the MySQL database. So first, when you hit this page, it is going to the Nginx web server. Nginx is then refreshing this page, providing this UI, and any calls to /API is now doing are getting reverse proxy to the Java application, Spring Boot application running on the same EC2 machine where the web app is running. And that Spring Boot application is now talking to the EC2 machine where the database is running, and it is getting all of this data and displaying here. Okay, so this is a typical monolith application. We have three layers: UI, which is front end, the business logic, which is the Java application, and the back end, which is the database. So three tier application, but we are running on two EC2 machines. Okay, now in the later labs, we will figure out how to modernize this monolithic application using microservices with the cloud native architectures. So this concludes the demo for the initial lab setup for the monolithic application. So one more thing we can verify is the backend. Okay, so what we are seeing is a front end. The Nginx is running on the EC2 machine, which is basically displaying this UI. And Nginx is talking to the backend via a different path. Okay, so to understand how that works, let us open one more tab and enter this URL. So here I entered the public IP of the EC2 machine and appended this path /API/unicorn. So if I just refresh this, you will see this data coming from the backend. So this particular output is coming from the Java application, which is a Spring Boot application running on the same EC2 machine. And any path with /API is redirected by the Nginx, to the backend application. Okay, so this is how we can verify that the front end and the backend are running on the same EC2 machine, and this path is reaching to the backend service application.